that's focused today on automation, APIs, and robotics. Just at a very, very high level, Onshape is a cloud-native set of services which are encapsulated in this box, or this circle, which includes 3D design, CAD design, but also the data management, the analytics, and the user management, and the security, and everything that goes around with that. So it's a whole set of services that are accessible. And around that, we have wrapped a REST API. So that's the way that you interact with the systems and the services that are inside. We use these REST APIs ourselves when we develop the web client and the other clients that go with Onshape. And we offer a very, very open and full access to these REST APIs. We'll get more into that in a second. Around that is an authentication layer. So we use OAuth and those sorts of other authentication methods and techniques to protect those REST APIs from unauthorized access. And they can be rate limited and throttled in certain ways, certain cases. Around that are the endpoints, right? So we offer these endpoints to get to this data get to the APIs through the authentication layer via these endpoints. And at these endpoints, we have lots of different bindings and different ways that you can do this. So whether you're developing applications for manufacturing or analysis or CAD, they all work the same way, that you make your HTTP request to the endpoints and get data back. And usually a JSON payload is how that comes back out. So yeah, none of this is new or particularly novel. It's just the way that modern web architectures are. And I think the first point is that this is how we've designed our systems to work. Now, there's different integration methodologies you can use and approaches depending on the scale and the how far and wide you want to spread the application. In fact, one example application is the Onshape web client. That's a very good kind of on one end of the spectrum. And we can look at some other things along the way, along that spectrum too. So a lot of these things on the next page will be available to you. You might have already stumbled or been delivered links along these ways. So we have this developer portal. And if you have credentials into Onshape, even as a free user, you can get into our developer portal, which has a lot of interesting things, including a getting started area, a list of the OAuth applications that you may have created already, and you can manage the tokens and things that are associated with that. And then your set of API keys that you'll need. You have to generate some API keys if you're going to get very far with this. And that's all at the developer portal level. There's a lot of documentation available for this. In fact, there's a number of different sources you can go for specific documentation based on here. A lot of things are supported and delivered on our GitHub repositories. A couple of links there that would be very interesting, including some very, very good project samples. And these are kind of worked examples that go along the different parts of the spectrum as well, from taking a command line Python approach to, say, bottling up those into Flask applications and running them through to hosting things on a Heroku or something like that. Because at the heart of it, you will have to find somewhere on the cloud to host, or let's say you have to find somewhere to host your application, and it's likely to be on the cloud, unless it's for local testing. There's some really good examples in here. There's also one I meant to add, which is our educational unit here at PTC has fully pivoted a couple of years ago, in fact, to Onshape as the tip of the spear of basically how we teach kids and older kids CAD and PDM these days. So PTC's all in on Onshape for that. And to that end, our education team have put an incredible amount of really cool stuff on their GitHub on their GitHub repository as well, including things that involve linking like IoT kind of applications where you have hardware that's running outside and then feeding back information directly, and Onshape responding to it in certain ways, and vice versa. Some really good examples like that in there as well. One of the most fundamental ones that you will be interacting with is our API Explorer, which is really the documentation of the APIs themselves. And there's a site called Glassworks here, and there's a link to it. And the Glassworks site is, I know, here it is. It's our API Explorer, right? And in it, you can go down and find all of the different endpoints that are in the REST API. And so if you pick on something like document, now within document, that will unfold into many, many, many different forms of that endpoint. So there's a particular get API or endpoint, which is /documents with a document ID after it. Now, if you invoke this endpoint, or if you hit this endpoint with your request, and there's an example of it kind of given, you get a certain response. Now, the good thing with the Glassworks API Explorer is that it lets you test this in live. So I've just plunked in before this meeting, I put in this document ID, and I did that by just copying out of the URL that I was working on, and then just hit the execute button. And down here is the response which came back. And this is a really simple, and it's actually a much longer response than you can see on there. For instance, if you hit the document ID endpoint, or the document ID endpoint, you'll get a list of all sorts of things about, when it was created, who was the owner, what are the sharing, all sorts of metadata as well about that document. And then it goes deeper and deeper and deeper, back to, this is a partial list here. Perhaps you wanted to, add a comment to an existing document. You can hit an endpoint to do that, or you can read the existing comments in the document. So you give the document ID, you give, all sorts of information. In this case, it might be you have to provide user authentication as well, and then you can get the response. And it's kind of up to you as the developer then to do something useful with the response. It's a JSON payload. We figure that you'll be able to do something with that. And there's really useful ones. This is 1/10 of the number of categories in here. As a quick kind of an example, and I know that we only have a few minutes today, so I will just highlight a couple of these things. Here's a really simple Python snippet that I just wrote a few minutes ago, and from a command line. So I imported the Onshape client, so we have a Python module for this, and imported a couple of modules from that. And then I set up a client which has authentication. So I needed to provide my key pair that was in there. Now, there's many different ways you can do this. You could use OAuth, but that's a little bit trickier than for a hello world. And then I asked Onshape to provide, open an element, right, and then provide me the mass properties, get the mass properties of all of the bodies in this document. And then I just printed out, multiplied that by some number, just to sort of simulate me from a Python client saying, tell me how much material is going to be needed to print this. So this is completely headless, right? You don't need a web browser running or Onshape running on anything. It's just me interacting with the Onshape service in the cloud. Your app could be doing this thing. Your app can be getting and posting to its heart's content across this type of thing. Right. So something on the next level of the spectrum is that when you have an application, you can put it inside the Onshape application. So this is a panel on the right-hand side of a normal Onshape client, which is the browser. And basically this panel will open up given on, if I click one of these specific icons. So this in here is an iframe, which is hosted inside the Onshape client. And with that, then you can communicate with your application. So this application was a really cool one, and this is an education unit created one called CAD Checker. What it does is it allows you to rapidly get information and maybe check it against maybe you've got a model, canonical model that you're checking against. So it will check mass properties. It'll check, whether you've got materials assigned, whether you've renamed features correctly. Just does a little bit of a teacher's class assessment for CAD. And the good thing with this example is that it's like a lot of the stuff is open source. You can download the sources for this from the GitHub and see how we did it. So what happens with this is that you click the button, the thing expands. You say whether you want to compare it against a list of models or whether you just want to get information about the document. This example was done for some CAD. I think Jenny correct me if I'm wrong, but it was done for a competition where users had to try and replicate something from a drawing. Yeah. And then the teachers were going to verify that it was indeed all their own work. You can see if copies were made or things were done that were outside of the bounds, and that sort of a thing. Yep. And so taking this, but all of the information, this was using OAuth, right, as the authentication between the two applications, ours and the host and the other one. It's rendering in here some pretty simple stuff, but let's take it to the next level. And the next level being a really good example here for some people that are based out of Austria. So they do, it's called Principia, this company. So they have a multibody dynamics solver that they've developed, and they are hosting that in some Kubernetes container somewhere, and they are interacting with the Onshape assembly and solving and then delivering the results back. This is actually an animation in here, like a 3D rotatable animation while we're doing the simulation. And you can extract some graphs like the force and component reactions at the certain joints and so on and so forth. So it's multi-body dynamics. It has the capability to do flexible bodies. We haven't unlocked that yet because what they need to do that is to grab our mode shapes from a modal analysis, to Craig Bampton method, do their stuff and bring back a multi-body dynamics solve with flexible bodies. This is getting towards the most sophisticated end of the spectrum for apps. But again, it's directly interfacing with the Onshape assembly, and the Onshape assembly has things like mates, or has the mates in it. We call them mates, right? The joints. So whether it's revolute ball joints, cylindrical joints, sliders, all of those things are defined in the Onshape assembly. So the user over here doesn't have to reassign anything. Right. So that's quite handy for being able to take someone who knows how to Onshape well, they can then simulate well as well. All right. So this is available in our app store already called Principia. If you want to check that one out. This one actually shows all sorts of great behaviors too, is that if I decide I want to at this point, which is like at 0.8 of a second or something, there's some big maximums and minimums going on, I can export those values of fx, fy, fz and create a variable studio of those values. And a variable studio is a tab or an element in Onshape here, which then I can refer to other design work. Right, maybe I'm going to apply a load to a static analysis, and I want the X, Y, and Z components to be at that maximum minimum kind of location. So, they've sorted this out well to do a two-way communication. They actually create Onshape entities, in this case, a whole variable studio from their app. And they're reading, they're writing, they're reading, they're writing. Like I said, the final example for now is called RoboForge. So RoboForge does a very, very similar thing, except in a totally separate environment. This is actually one window. I realize it made it look like two browsers next to each other, but it's actually one window with a kind of split in between it. It takes an Onshape assembly and prepares a URDF model of it. And it understands the joints again, the mates, from the Onshape model. So ball, cylinder, revolute. And as long as you name them, well, if you name them correctly, or sorry, sensibly down here, that will translate into the names of the joints in the URDF. And then it also has some export from that. So you can export directly to a RViz or Gazebo or Mujoko. Yeah, one of the other kind of URDF-based formats. So that will take in, and if you squint, you might be able to see it, but you know, it'll create the collision convex hull. It'll create all sorts of other information that the URDF model is requiring or optionally requiring. And you can test it out in here on the. You can test out each of the joints individually. It's a kind of a little preview environment. But obviously, the next step from this is to take the output URDF and take it into whatever, or program up whatever environment. Thanks very much.